Ladies and gentlemen, welcome to the Big Bear Math channel. We're focusing on algebra foundations where we're solving equations in one variable. We couldn't be happier that you've landed here in Big Bear country as we work alongside you and try to build your algebra confidence. And I don't know, maybe you're efforting your way through a challenging homework assignment, you're sitting at the kitchen table, or maybe you're just trying to review for an upcoming test. No matter the circumstances, we're going to tackle this bear together. And a couple of definitions here to get things started, just so we're all on the same page. What is an equation anyway? Well, simply put, an equation is basically a statement formed by placing an equal sign between two algebraic expressions. So we're going to look at some examples and some non-examples here. So first of all, maybe some non-examples actually. So a non-example would be 4x minus 2. But if I take that 4x minus 2 and I set it equal to 3x plus 1, now all of a sudden I've got an equal sign, I've got an equation. Or maybe another non-example would be 2 quantity x plus 5. All that is one single algebraic expression. But once you take that quantity and you set it equal to something, now we've got something cooking. We've got ourselves an equation. So what we're going to do is we're going to be focusing on solving equations. We're going to come up with solutions. What are solutions? By definition, a solution is going to be any value that you could substitute in place of the variable that makes the equation true. Now, wait a minute. What do you mean by making the equation true? Okay, so let's see if we can take a look at a true versus a false, so to speak. Let's see. So our first one says, is x equals 3 a solution? So what you're going to see me do is replace that x with a 3. So I'm going to go 2 quantity 3 minus 3 equals 5. 2 times 3 makes 6. But what you'll notice is 3 does not equal 5. So that's an example of a false statement. In other words, 3 is not a solution. Now, let's try the next one here. Is x equals 4 a solution? So I'm going to replace the x with a 4. Love that word, replace. 2 times 4 makes 8. And 8 minus 3 does indeed make 5. So 5 equals 5. This is considered a true statement. And now we're concluding, yes, x equals 4 is a solution. So we're very excited about that. In general sense, how do we solve an equation? Let's keep it really, really simple, shall we? All right, first step. You're going to transfer, or I really like the word isolate, all of your variables to one side of the equation. So we could kind of cluster or herd them all to the left of the equal sign or all to the right. It really doesn't matter. There's no right or wrong process there. But whatever you choose, we're going to then transfer or isolate all of our numbers to the opposite side of the equation. And to accomplish these two steps, we're going to be using these inverse properties. So for instance, what is the inverse of addition? Well, that's going to be subtraction. So if you see a plus 2 and you want to move it to the other side, we're just going to subtract 2. Or what's the inverse of that should say subtraction there. Typo on my part. So the inverse of subtraction is going to be addition. What's the inverse of multiplication? Well, that's going to be division. Or the inverse of division is going to be multiplication. Those 4 key elements right there, which may seem very simple to you right now, are going to be the key foundation to solving all sorts of equations throughout your math career. So without further ado, let's dive right in and see what we can solve here together. All right, question number 1. We'll try a little light blue here. So what I want to do is I want to transfer or isolate all of the variables on one side. And usually what I do is I try to move the smaller variable term to the side that contains the bigger variable term. So I'm going to subtract 2x. Now you might be wondering, why am I subtracting? Well, this 2x right here is positive. So the opposite or the inverse of a positive 2x is going to be a negative 2x. And again, the other thing you'll notice here is whatever you do to one side of the equation, so if I subtract a 2x from the left side, I have to then subtract a 2x from the right-hand side. Whatever you do to one side, do to the other. So these cancel out, and you're left with 10 equals 2x. Now what you're reading right here is 2 times 2x, or I'm sorry, 2 times x. So the inverse is going to be division. Whatever you do to one side, we got to do to the other. And ladies and gentlemen, x equals 5. All right, let's see what we got cooking over here. Let's see. So who's bigger? I'm going to say 2x is bigger than negative 6x. So because of that, I'm going to add a 6x to this side, and I'm going to add a 6x to that side, thus making 8x. Everything else just gets carried down, and those canceled. Next, what I'm going to do is I got to move the numbers to the opposite side that I just moved the variables to. So I'm going to move the negative 9 by adding 9 to both sides. And you're going to get 8x equals 16. The inverse of multiplying by 8 is to divide by 8. Whatever I do to one side, I'm going to do to the other. And my solution ends up being x equals 2. All right. Just a mini little bear trap here. All right. So the first thing, when I saw those parentheses, I said, I wonder if I can simplify anything inside of those parentheses. Now, maybe your first instinct was to distribute the 3, and you wouldn't be wrong necessarily, but I think there's an easier approach that in the long run will prove to be more beneficial. What I'm going to do is I'm going to combine this term with this term. Those are considered like terms. And when I combine them together, I get 3m. Because what I'm doing is I'm taking a 1m, combining it with a 2m to make a grand total of 3m. Now I'm going to distribute this 3 to make 9m minus 15. I'm going to add 15 to both sides, which I bet you anticipated. Those cancel. We're left with 9m equals 27. Oh, yes. Now, the inverse of multiplying by 9 is going to be divide. Whatever I do to one side, I do to the other. M equals 3. Bingo, bingo. Winner, winner. Chicken dinner. All right, what color? Let's finish with a little purple, eh? Now, in this particular case, I am going to go ahead and distribute the 4 right away just because there was nothing I could combine within those parentheses. So I'm going to get 8a plus 12 equals 4a minus 28. Now, who's got the bigger variable term? Let's say 8a is bigger than 4a. So I'm going to try to move the 4a to the left. And to do that, I'm going to subtract 4a from both sides. 8a minus 4a makes 4a. Carry the 12 down. Cancel these bears. Now, watch that 28. If I just put a positive 28, it's going to cause an error. Make sure we carry that negative sign down or that minus sign down. Now I got to move the numbers to the opposite side. So the inverse of positive 12 is negative 12. Cancel those. 4a equals negative 40, I believe. You can always check that on my calculator. And then if I divide both sides by 4, I'm going to get a equals negative 10. Now, what's really nice about all of these answers today, and I haven't talked about it yet, is you can check every answer. Assuming you've got enough time on your homework or your test or whatever you're working on, we could take this negative 10. Whoopsie daisy. We could take that negative 10 and substitute it back into the original right there, as well as right there, and then work it out to see if I got a true or false statement, similarly to what we did earlier in the video to see if x equals 4 was a solution. So ladies and gentlemen, I hope that it helps you feel a little more confident with solving equations in one variable. We're really practicing and honing our fundamentals here tonight. And if you found this video helpful, please hit subscribe below. We'd appreciate nothing else more. And share this with your friends. And come on back and check out some future topics.